Yeah, wait 1 minute. Here, this is the fourth experiment in OS. It is to write the program implementing of CV schedules algorithm for the first commands using several uh, SJF. Here I have taken as FCFS, and burst time I have going to take, or I'm going to take as a burst time. Wait, and the have print the process burst time and waiting time and turnaround time. Then I is equals to 0. Then wait time is equals to 0. Turnaround time is equals to 0, and empty1 is equals to null, and empty2 is equals to null, while the loop I is greater than length of burst time. Then turn around the time, and the burst time is equals to I, and print the process string of I plus 1 and t slash t slash t slash t up to 5, and string burst time of I, and string wait the time, and around time empty of 1 is equals to append dot waiting time, empty2 is equals to append dot turnaround time, waiting time plus burst time of I plus is equals to 1, then return empty is equals to 1, empty2 for np hint input enter the number of processors. Means you have to enter the number of processors here. Then the burst time is equals to null for I in range of np. The burst time appends hint input enter the burst time for process. Here you have to enter the what's the value you are taking for the burst process plus string of I plus 1. Then list of FCFS burst times. Then print the average waiting time. Here you have to print the average waiting time. And then string sum of list is equals to 0. You have to print the list is equals to 0, and the list equals to 0. After that, print the average turnaround time. Turnaround time is equals to string of sum list equals to I, length of list equals to 1. Then I am going to execute the program. Here the process what you are going to take means the process I am going to take as 3, and I am going to press as enter, and 1 as 24, enter, and 3 enter, and 3 enter. This is the time. Enter the burst time of processor 3, and this is the process p1 p2 p3, and burst time is equals to 2433, and this is the waiting time. This is the waiting time. The average waiting time is equals to 17.0, and average turnaround time is equals to 27. This is the first one, and this is the second one. That is to SJF. Here also same. I is equals to 0. The waiting time is equals to 0. Then time is equals to 0. Empty of 1. Empty 2. While I is greater than length burst time. Then turnaround time, burst time, and then print. You have to print that string index burst time. Then I plus 1 plus again string you have to take, string waiting time and string turnaround time. Then x independent burst time is equals to I is equals to -1. Then empty of 1, append waiting time, empty of 2, appends turnaround time, and after that waiting time is plus equals to bursting time of I, I plus is equals to 1, return empty 1 is equals to 2, np is equals to hint input. Here we have to go as the input, enter the number of processors. So what the processor you are going to give, you have to enter the processor, and for I in the range of np, then burst time you have to enter the burst time appends hint input, enter the burst time for the processor, you have to enter the time for the processor, and then string I plus 1, then list of SJF sorted burst time. What's the time for burst time? Print the average waiting time. What's the average waiting time? Here we have to print, and string sum of list of 0, length of list 0, print the average turnaround time, and string sum list on the length of the string. And I am going to run the program. It's asking to enter the number of processors. What the processor we are going to enter means, I am going to enter as 3, enter, and 2 as 24, enter, and 3, enter, and again I am going to enter as the executing burst time as 3 and enter. Then the average time, the average turnaround time. What is the average time? The average time is 3, and the average turnaround is 13.0. And then after this third one, it's a round robin. It's about the round robin. Here copy 1, copy 2, processor of I plus 1, while copy of 2 k is greater than 1, copy of 2 none, w is not equals to length of copy, then I in the range, and this is the program, and I am going to run this one. It's asking about the processor. What's the processor you are going to give? The processor I am going to give as, the processor I am going to give as 3, enter, 24, enter, and number 3, enter, and number 3, enter. Then it's asked as the time query. What's you are going to give as a time query? Quantum I am going to give as 5, and I will press enter. Here the average waiting time is 6.333 some value, and average turnaround is 16.3. You will get the average as well as the waiting time what you are getting here. And this is the last program. It's about priority. Here we have to print the processor burn time and waiting time, turnaround time you are going to take. And after that I is equals to 0. Then after that waiting time, what's the waiting time you are getting is 0, and turnaround time is equals to 0, and empty 1 and empty 2, while I is greater than length of burst time, k is equals to priority, turnaround time, burst time, and the priority dot index of k, print k is to k plus string, priority index, then string burst, then waiting time, then the empty of 1 is equals to appends. You have to append wait the time, and append 2 is equals to appends of turnaround time. Here we have to calculate as waiting time and turnaround time. Waiting time is equals to burst time of priority index, then I is equals to I is equals to 1, then priority index maximum priority plus 1. Here you have to, the logic is the maximum priority plus 1, and return empty 1 and empty. Here you have to go again, you have to return the empty 1 and empty 2, np hint input, enter the number of processes. Here you have to go enter the number of processes, burst time and priority. And okay, I'm going to execute the program. (24) enter, 3 enter, 3 enter, 5 enter, 2 enter,